Hi, I'm Yuvraj.
I'm Ryan.
I'm Jeff.
I'm Abdul.
I'm Grace.
And I'm Benjamin.
Today we'd like to introduce you to the Enhancing Citizen Science and Accessibility with an Automatic AOI web app. We'd like to begin with introducing what is AOI. AOI stands for Area of Interest. It is a standardized data set that can create a high-resolution model of an area, set of coordinates that map an area, and citizen scientists use this app to record observations.
So we, as Earth Science Explorers, have found some issues with Globe. First off, that AOI can only be found externally, and that makes it very hard to navigate as people who are not necessarily very experienced with computer science and earth science. So in order to understand the limitations of the Globe Observer, we surveyed all of the Earth Science Explorer interns and asked them 2 questions regarding their Globe experience. How convenient was the AOI creation process, and how likely were they to repeat the process? We found that many of the interns found that the process was very inconvenient and that they would not repeat the process outside the internship.
It's pretty clear that Globe and AOI creation can be difficult for citizen scientists and SEAS interns alike. So to address this issue and enhance overall experience for future SEAS interns, we aim to develop an app focused on streamlining the AOI process. We hope to answer this research questions. Does the app function in creating an AOI both effectively and optimize citizen science users' comfortability? And if it does it hold up to the current system we have in place?
So some of the potential benefits of a project like this is that it could impact over 10,000 citizen scientists that would use the Globe Observer app in the future. It could significantly bolster retention among volunteers because they'd be more motivated to help out if they see more researchers available and they see that it's easier to get access. And it could also increase land cover accessibility to more people. So our research plan has 4 steps. 1, identify specific features that can optimize user experience. 2, develop those features in a preliminary web app. 3, compare the app with current systems using volunteers. And 4, consider and modify features as needed until we get to our final product.
Welcome to our app demo, which is built using ASP.NET Core, hosts a PostgreSQL database, and uses TypeScript for interoperability. Now, after getting to the login page, the user can go to the register page to enter their details. Here we can enter your name. This allows you to log back in after you log out to see your saved data. Now I'm back to the login page. I'll enter my details. Now I'll be greeted by a big map and a side dashboard. You'll see your current location as an icon. You can long press on a point. This will be your center for your grid now. And you can click create grid. This will give you a quick confirmation and you can create the grid. On the left side, you'll notice that your points pop up with the number, with the positions. This allows you to track your data collection. And the pins pop up on the map. Now, if a pin is in an undesirable location, for example, this is in water, I could slightly move it over to an accessible location, and this is just for better organization. It's not really significant. If I'm in a location and I want to go to the n nearest points, I don't know which are the closest. I could do this. I could say I want to go to the 3 nearest points, for example, and it would give me a quick route. After I'm done collecting a point, for example, let's say I collect this point, right? So I can scroll down to 16 and I can check it off. And now this will take you to the bottom, to the collected area. Pending will decrease by 1, etc., etc. And the pin will turn green. So when the whole grid turns green, that means you're done collecting. Thank you for watching our demo.
So now that we've seen that demo, it's important to compare our system with the previous system. So we did that by contacting 20 volunteers across the continents of the US, and we instructed them to one group to use the old AOI system and one group to use our system. Then we instructed them to visit all the coordinates on the AOI and do mock observations and time each step of that process, and then swap to either our system or the old AOI system, and then have them do a post-survey review. So we found that the AOI creation process, our new web app was significantly faster than the old system, and we found that the data collection process was significantly faster as well because of the grid.
Okay, so future steps, we're hoping to build a mobile app to incorporate more features, customize the AOI grid to 3km by 3km, and create multiple AOIs from the user account, and more organic tasks between points for navigation. In conclusion, we learned how to make an AOI 37 points more accessible, change the ability of more data for NASA landscapes, and create a new app for ideas to fix the AOI grid, and change the effects of the inaccessibility of the AOI grid. We would like to thank Rusty, Lowe, Peder Nelson, Cassie, Soeffing, and AJ, Caesar, and Andrew Clark for their help on the project. Thank you so much for watching.